Okay, so question 2. The height y in meters of a sea wave impinging on a tidal power generator at time t seconds is given by the formula y is equal to 1.7 cos of 1.15 t plus 0.42. The result, the units are in radians. Now, you may not be told this explicitly, but you can glean that from the fact that there's no degree symbol here, or instead of 0.42, a decimal, you might be given it as a fraction of pi, which would give you a clue that we're in radians. What we're asked to do is find the first value of t for which y is equal to minus 0.65 meters for t greater than 0 seconds. Okay, so this is a straightforward question once you know what to do and where to start, and we're just going to solve this like we have all the other examples. First thing to do is we're going to replace this y with the y that we're interested in, this minus 0.65. So what we're going to do is we're going to write 1.7 cos of 1.15 t plus 0.42 is equal to minus 0.65. Now, the first thing you'll know is that yes, we've got a period coefficient of 1.15, so we are going to have multiple solutions here. However, what we're asked to find is the first value. We're asked to find the first value of t for which y is equal to this. So what we're going to do is we're going to find just one period for t, and we're going to take the first value for which it equals this. So we don't have to go and add on the period to any of this. We're just going to go ahead and do this. So the first thing to do, we're going to take this 1.7 to the other side, which leaves us with cos of 1.15 t plus 0.42 is equal to minus 0.65 over 1.7. At this point, what we can say is that the cosine function is negative. Because we've got this negative sign in front of this fraction. So we can use this when we come to our quadrants to find out which quadrants we want. So at this point, what we're going to do is we're going to drop the minus sign. Next, we're going to take the inverse cosine of both sides. So we're going to be left on the left hand side of this equal sign with the argument of the cosine. So we've got 1.15 t plus 0.42 is equal to the inverse cosine. Now we've dropped the minus sign, so we're just going to keep this as positive. So 0.65 divided by 1.7. Alright, we can go into our calculator and do this. We're going to make sure it's in radians mode. So we're going to shift mode setup and press number 4 to make sure it's in radians mode. And we've got the R in the corner there. Let's move that there. And we're going to have the inverse cosine. So shift cos, we're going to put the fraction button there. 0.65 divided by 1.7. Hit equals 1.178 to 3 decimal places. So that equals 1.178 to 3 decimal places. And that'll be in seconds there. Okay, so now we're going to do our cast. So let's draw this. I'll try and draw this as neatly as I can. Oh, that's not very good. Oh, it'll have to do. So we've got cast here. Now because cosine is negative, we're going to be in these two quadrants. Because in quadrants 1 and 4, cos is positive. So in quadrants 2 and 3, we know that the cosine is negative. So let's go ahead and calculate T1. So I'll put it here, T1, and I'll put that in a big box there. What I'm going to do is I'm going to rewrite this out. So we're going to be in quadrant 2 here, so I'm just going to put quadrant 2. So we know we're going to be pi minus this answer here. So 1.15 T1 plus 0.42 is equal to this 1.178. Sorry, it's going to be this pi minus this 1.178. So pi minus this 1.178. Now we've got a calculator. So I'm going to put pi minus 1.178. And that gives us 1.964 to 3 decimal places. Okay, I'm putting S because we're in seconds for this. So let's solve for T1. So I'll do this in stages. 1.15 T1, and we're going to take this phase shift to the other side. It's going to be 1.964 minus 0.4. Sorry, yep, minus. I was right. 0.42. So I've already got that there. So I'm just going to put answer minus 0.42. It's 1.544 according to this. 1.544. Now we're going to take this 1.15 and take it to the side. So T1 is equal to 1.544 over 1.15, and that should give us T1. I'm going to put that there. I'm going to so answer divided by 1.15. That's 1.32. 1.342, sorry. Seconds. So I'm just going to underline that one. And okay, so let's go to the other side and let's calculate T2. We're going to be in quadrant 3 for this. So I'll put quadrant 3. And it's going to be pi plus this 1.178 that we calculated. So just remind you, we calculated this 1.178 earlier on. We're in quadrant 3, so it's going to be pi plus that to get our angle. So I'll go 1.15 T2 this time, plus 0.42 is equal to pi plus 1.178. So I'm going to go shift pi plus 1.178. 4.319. So this 5 rounds this 9 up. So it'll be 4.320. Whoops. 4.320. Alright, so now we can take this phase shift to the side. 1.15 T2 is equal to 4.320 minus 0.42. So that will come to 3.8995. So round this to 3 decimal places. This 9 rounds up, which then carries on to that. So it'll be 3.900. So just make sure we've rounded that correctly. 3 decimal places. It's 5 rounds that 9 up to a 0. That propagates that. So that rounds up to 10, which rounds it to that. So that'll be 3.900. Now we can solve for T2. So T2 is equal to 3.9 divided by 1.15, which gives us divided by 1.15, 3.39 seconds. I'm going to underline that one as well. So we can see, in fact, that T1 was the first solution when y equals the height that we're after. So we'll just write a note at the end saying that T1 is equal to 1.342 seconds is the first time y is equal to minus 0.65 meters. And there we have it.